Hello dear students, today we are going to discuss the next chapter, that is a solution chapter for 12th class chemistry. So जिस तरह ਆਪਾਂ 12th class subject ਦੇ ਲਈ full lecture solution chapter ਦਾ ਲੈ ਕੇ ਆਏ ਹਾਂ, so ਇਸੇ ਤਰ੍ਹਾਂ ਬਾਕੀ chapter cover ਕਰਾਂਗੇ. So start ਕਰਦੇ ਹਾਂ first chapter, that is a solution. So solution, that is a mixture of two or more pure substances. So definition is, this is a homogeneous mixture of two or more pure substance whose composition can be varied with the certain limits. So ਇਹਨਾਂ ਦੀ variation composition ਦੀ vary ਕਰ ਸਕਦੀ ਹੈ. That is mixture of solvent solute to form a solution. Solvent can be taken as A abbreviation, solute that is B, and solution AB component. ठीक है. So this is the abbreviation used in this chapter. Next, that is a binary solution. Binary, that is a solution that is consisting of only two components, that is called as a binary solution. ठीक है. So the two components are solute and solvent. So solute, the amount of substance or the component which is taken in lesser quantity, that is a solute, and the component which is present in excess of quantity, that is a solvent. ठीक है. So mixture, that is a combination of solute and solvent. Next, most important, that is a types of solution that will consist of three phases, that is a solid solution, liquid solution, gaseous solution. In solid solution, that is a combination of solid in solid, liquid in solid, and gas in solid. So first, that is a solid in solid, that is a copper dissolved in gold. Second, that is a liquid in solid, amalgam of mercury with sodium. Third, that is a gas in solid, that is a solution of hydrogen in palladium. ठीक है. And liquid solution, that is a liquid in solid in liquid, liquid in liquid, and gas in liquid. So solid in liquid, that is a glucose dissolved in water. Liquid in liquid, that is a ethanol dissolved in water. Gas in liquid, that is a oxygen dissolved in water. So these are the liquid type of solution. Last one, that is a gaseous solution, that is also a mixture of a solid in gas, liquid in gas, gas in gas. So camphor in nitrogen gas, that is a mixture of solid in gas, gaseous solution types. Chloroform mixed with nitrogen gas, that is a chloroform, liquid in the gaseous form, nitrogen gas, so that is gaseous solution types. Gas in gas, that is a mixture of oxygen and nitrogen gas. So these are the different types of solution. So these are very important topic from this. Many questions are asked in the competitive exam. So next, that is a chapter topic is, that is a concentration. So concentration, that is the amount of solute that is present in mass of solvent, that is called as a concentration. So basic part. So method for expressing the concentration solution are, so first, that is a mass percentage. So mass of the compound is per 100 gram of the solution, that is the mass of solute, mass percentage of solute, that is a mass of solute divided by total mass of solution multiple by 100. Similarly, mass percentage of solvent equal to mass of solvent divided by total mass of solution multiple by 100. So for example, if 10% glucose in water by mass means 10 gram of glucose dissolved in 90 gram of water and resulting in formation of a 100 gram solution. So next one, that is a volume percentage. So volume percentage is the volume of component in ml that is present in 100 ml of solution. So volume percentage of solute, that is the volume of solute divided by total volume solution multiple by 100. Volume percentage of solvent can be calculated the volume of solvent over total volume solution multiple by 100. So for example, if 10% of HCl solution in water means 10 ml of HCl dissolved in 90 ml of water resulting in 100 ml of solution. Similarly, next, that is a mass by volume percentage terms. So if the mass of solute is dissolved in 100 ml of solution, so mass by volume percentage, that is a mass of solute divided by total volume of solution multiple by 100. So a 10% mass by volume of solution means that 10 gram solute present in 100 ml of solution. Next term, that is a ppm, is known as the parts per million parts. So ppm, that is used when solute is taken in trace quantity. This is very important, so from which MCQ has been asked. And it is the number of parts of a component, parts per million parts of the solution. So ppm, that is a mass of component, mass of solution multiple by 10 raised to power 6. So 10 raised to power 6 ना multiple करेंगे अपन, so that will give answer in the ppm form. Next term, that is a concentration term, most important, mole fraction. So it is defined as the ratio of a number of moles of one component to the total number of moles of present in the solution. So mole fraction of component, that become equal to number of moles of component divided by total number of moles of a component. ठीक है. So next one, for example, so if we have binary mixture, that is a mixture of A and B component. So number of moles of A and B are Na and Nb respectively. Then mole fraction of A component Xa become equal to Na over Na plus Nb. Similarly, mole fraction of B Xb become equal to Nb over Na plus Nb. So if sum of both the terms Xa plus Xb, that will give one value. So this is the fundamental result. So if we have one concentration term value is given, then another can be calculated by subtracting from one. Okay. So units, in case of units, that is a mole fraction has no unit. Okay. This is a dimensionless quantity. Next, that is a molarity. Molarity denoted by capital M. So it is defined as the number of moles of solute dissolved in 1 liter of the solution. So it can be written as number of moles of solute divided by volume of solution in liter. So it can be written as molarity equal to number of moles, that is a given mass over molar mass, that is W2 over M to given mass over molar mass of solute. Okay. Multiple by 1000 divided by volume that is taken in the ml. Okay. So it can be defined as a 1 molar. So if 1 gram of mole of solute present in 1 liter of the solution, the concentration of solution is said to be 1 molar. Okay. And molarity, that is a dependent of temperature. The reason is that here is the presence of volume term included in the formula and definition. So due to that, upon temperature variation, volume of the solution can be vary, and hence that effect on the molarity value. Second, and units, and in case of units, that is a mole per liter is the units of a molarity. This is the important form. Next, that is a molarity. Molarity, that is, it is defined as the number of moles of solute dissolved in 1 kg of a solvent. So molarity denoted by small m, that is the number of moles of solute divided by mass of solvent in kg, that is the m. Wb over mp multiple 1000 over Wa. So thus if 1 gram molecule of a solute is present in 1 kg of solvent, the concentration of solution is said to be 1 molar. Okay. So molarity is the one of the most convenient method to express the concentration, because it involves the mass of liquid rather than that of volume. So out of molarity and molarity, which term is the best term? So to express the concentration term, so as we know, that is a molarity, there is a presence of mass of solvent and mass of solvent, and in case of molarity there is a volume term included. So due to the volume, that is a temperature dependent quantity, so due to that, it is, its value can be vary, and molarity, its value does not vary because the volume term is not included here. So that's why the molarity is a convenient method, okay, to express concentration, and it is also independent variation of temperature. Okay. Next, that is last, that is a units, and molarity, that is a molarity unit, that is a mole per kg are the units of molarity. Okay. Next term, that is the normality. So it is the number of gram equivalent of a solute dissolved in 1 liter of the solution, that is the normality. Normality, that is the number of gram equivalent of solute, volume of solution in a liter, normality. So it can be written as weight, given weight, equivalent weight 1000 over volume in ml. Okay. Next, a special note, the most important part here, mass percentage, ppm, mole fraction, and molarity, that is independent on temperature quantities. Okay. So many times these type of question are asking the, and molarity is the function of a temperature, because volume depend upon the temperature and mass does not. Okay. So next, problems of based upon the concentration quantities. So let's start from the first. What is the weight percentage of urea solution in which 100 gram of urea that dissolve in 90 gram of water? So mass percentage of urea become equal to mass of urea over total mass of solution multiple by 100. So put करेंगे वैल्यू इतने, 10 gram urea, total mass that is a 90 plus 10 multiplied by 100, that will give 10%. Next, second, 3.65 gram of HCl gas is present in 100 ml of its aqueous solution. What is the molarity? So molarity, that is a formula, given mass over molar mass of solute multiplied by 1000 divided by volume, that is ml. Molarity that can be written as 3.65 divided by 36.5 multiple 1000 over 100, that will give 1 molar is the answer of molarity. Next, that is again similar type of numerical. Calculate the molarity of a solution containing 5 grams sodium hydroxide in 450 ml of a solution. So given mass 5 grams sodium hydroxide and molar mass that is a 40 gram, volume is given 450 ml. So the definition of molarity and formula is Wv over Mb, given mass of solute divided by molar mass of solute multiplied by 1000 divided by volume taken in ml. So 5 over 40, that is a 1000 over 450, upon solving that will give 0.278 mole per liter. ठीक है. Next, I calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. So molality is equal to Wv over Mb multiple 1000 over Wa. So molarity is equal to the 2.5 over 60 multiplied by 1000 over 75, that will give 0.556 mole per kg. So this is the molarity of 2.5 gram of ethanoic acid. Next, that is find the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. So 20% meaning that is a 20 gram of ethylene glycol, that is a solute dissolved in 100 gram of solution. ठीक है. So that is a mass of glycol, that is a 20 gram, mass of water that is a 100 minus 20, that is a 80 gram. So number of, first we have to calculate the number of moles of both glycol and water, then find out the mole fraction of ethylene glycol. So number of moles of glycol, that is a given mass over molar mass. ठीक है. So that is a 20 over 62 molar mass, that will give the 0.33322 mole. ठीक है. Similarly, number of moles of water, that is a given mass of water, that is a divided by molar mass, that will 4.44 mole. So mole fraction of ethylene glycol, that is equal to number of n glycol over n glycol plus water, that will give the 0.322 over 0.322 plus 4.44 will give the 0.07676 is the mole fraction. So mole fraction of ethylene glycol is calculated by this method. Next, the important term, that is the solubility. So it is the maximum. So what is the solubility? Solubility, it is the maximum amount of a substance that can be dissolved in a specified amount of solvent at a specified temperature. कि किसी एक फिक्स टेम्परेचर ਤੇ ਫਿਕਸ ਅਮਾਉਂਟ ਸੋਲਵੈਂਟ ਲੈ ਕੇ ਉਹਦੇ ਵਿੱਚ ਜਿੰਨਾ ਅਮਾਉਂਟ ਆਪਾਂ ਡਿਜ਼ੋਲਵ ਕਰਦੇ ਹਾਂ, that will give the solubility. ठीक है. So solubility of a solid in liquid, that can be defined as a solubility of a solid in liquid that depend upon the nature of solute and solvent. डिपेंड करेगा ਜਿਹੜੀ ਚੀਜ਼ ਡਿਜ਼ੋਲਵ ਕਰਦੇ ਪਏ ਤਾਂ ਜਿਸ ਦੇ ਵਿੱਚ ਡਿਜ਼ੋਲਵ ਕਰਦੇ ਪਏ, ਦੋਨਾਂ 'ਤੇ ਡਿਪੈਂਡ ਹੈ. ਫੋਰ ਐਗਜ਼ਾਮਪਲ ਆਪਾਂ ਵਾਟਰ ਲੈ ਲੈਂਦੇ ਹੈਗੇ, ਵਾਟਰ ਦੀ ਨੇਚਰ 'ਤੇ ਵੀ ਡਿਪੈਂਡ ਹੈ, ਅਤੇ ਵਾਟਰ ਦੇ ਵਿੱਚ ਅਗਰ ਨਮਕ ਐਡ ਕਰਦੇ ਹਾਂ ਆਪਾਂ ਜਾਂ ਸ਼ੂਗਰ ਐਡ ਕਰਦੇ ਹਾਂ, ਉਹਨਾਂ ਦੋਨਾਂ ਦੀ ਨੇਚਰ ਦੇ ਉੱਤੇ ਡਿਪੈਂਡ ਹੈ ਕਿ ਉਹ ਡਿਜ਼ੋਲਵ ਕਰਦੇ ਕਿ ਨਹੀਂ ਕਰਦੇ. ठीक है. सो फॉर एग्जाम्पल अगर देखिए आप ईजिली जोड़े है शुगर अगर तो वार्म वाटर होएगा उन्हें जल्दी डिजोल्व कर जाती है, अगर कोल्ड वाटर होएगा उससे थोड़ा जहा लेसर दैट दे विल टेक टाइम. ठीक है. सो डिफरेंट फिनोमेना. सो here the solubility that depend upon the word, that is a basic fundamental like dissolve like word means if the polar solvents, polar compound, that is a polar or ionic compound like NaCl, KCl, these are polar solute that will dissolve in the polar solvent like water, and non-polar covalent or organic molecules can dissolve in non-polar compound like benzene. ठीक है. So when a solid solute that is added to the solvent, some solute dissolve and some is and its concentration increases in the solution. So the ability of the solute to dissolve in the solvent, that is known as a dissolution. So जिन्नी ability ਹੁੰਦੀ है solute ਜਿਹੜਾ dissolve करता पे है solvent ਦੇ ਵਿੱਚ, that will give the dissolution power of that solution. So some solute particle in the solution collide with the solid solute particles and get separated out of solution, that is called as a crystallization. So many of the particles remain as it is, that will give the crystallization. So a stage is reached when two processes occur at the same rate. So under such a condition, the number of solute particles going into the solution will be equal to the solute particles separating out, and a state that is a dynamic equilibrium. So कई बार की ਹੁੰਦਾ है solute solvent ਜਦੋਂ mix ਕਰਦੇ ਹਾਂ ਆਪਾਂ, ਜਿੰਨਾ amount mix ਕੀਤਾ ਉਨੇ amount ਦਾ solution prepare ਹੋ ਰਿਹਾ, that will exist in dynamic equilibrium with each other. ठीक है. So a solution in which the no more solute can be dissolved. So ਜਦੋਂ ਇਕੁਇਲਿਬਰੀਅਮ ਆ ਜਾਂਦਾ, ਕਈ ਵਾਰ ਕੀ ਹੁੰਦਾ ਕਿ ਸੋਲਿਊਸ਼ਨ ਜਿਹਦੇ ਵਿੱਚ ਜਿੰਨਾ ਮਰਜ਼ੀ ਸੋਲਿਊਟ ਐਡ ਕੀਤਾ ਜਾਵੇ that does not dissolve, so that is called as a saturated solution. For example, ਅਗਰ ਆਪਾਂ having ਇੱਕ ਗਲਾਸ ਵਾਟਰ ਦਾ ਲੈ ਕੇ ਉਹਦੇ ਵਿੱਚ ਅਗਰ ਆਪਾਂ ਚੀਨੀ ਡਿਜ਼ੋਲਵ ਕਰਦੇ ਹਾਂ, ਚੀਨੀ ਡਿਜ਼ੋਲਵ ਕਰਦੀ ਜਾਂਦੀ ਕੁਝ ਮੰਨ ਲਓ 10 ਸਪੂਨ ਜਦੋਂ ਐਡ ਕਰ ਦਿੱਤੇ ਉਹ ਡਿਜ਼ੋਲਵ ਹੋ ਗਿਆ। ਸੋ ਆਫਟਰ ਦਾ 10 ਸਪੂਨ ਜਦੋਂ ਨੈਕਸਟ ਸਪੂਨ ਆਪਾਂ ਸ਼ੂਗਰ ਦਾ ਐਡ ਕਰਾਂਗੇ ਡਿਜ਼ੋਲਵ ਨਹੀਂ ਹੋ ਰਿਹਾ, ਦੈਨ ਦੈਟ ਸੋਲਿਊਸ਼ਨ ਇਜ਼ ਦਾ ਸੈਚੂਰੇਟਡ ਸੋਲਿਊਸ਼ਨ ਐਟ ਦਾ ਟਾਈਮ ਵੈਨ no more solute can be dissolved at that time. ठीक है. and a solution which more solute can be dissolved the same temperature, अगर ਉਹਦੇ ਵਿੱਚ ਐਡ ਕਰੀ ਜਾ ਰਹੇ ਤਾਂ ਉਹ dissolve and the solute dissolve हो रहा, that is called as a unsaturated solution. So this is the difference between saturated and unsaturated solution. For example, unsaturated solution, that is a more solute dissolve, saturated no more solute dissolve, and super saturated crystal may grow, ਜਿਹਦੇ ਵਿੱਚ ਕੀ ਹੈ crystal ਬਣਨੇ start ਕਰ ਜਾਂਦੇ ਹੈ। ठीक है. So these are the three basic differences. Next, a factor affecting the solubility is most important topic है. So first I under that is a nature of solute and solvent. As we know what the like, that is a like dissolve like. ठीक है. Like dissolve like, if we have the polar solute that will dissolve in polar solvent, and if the non-polar solute that dissolve in non-polar solvent, so that is will give the interaction. ठीक है. So strong solute solvent attractions increase the solubility, while weak solute solvent attraction that is a decrease the solubility. तो solubility increase कदों होएगी ਜਦੋਂ solute solvent attraction increase होणगीਆਂ, solubility while weak solute solvent attraction decrease the solubility. जितनी attraction ज़्यादा हो जाएगी solute solvent दी उन्नी ज़्यादा dissolution भी बढ़ जाएगी, उसकी solubility बढ़ जाएगी. So that's why the polar solute tend to dissolve best in polar solvent, and while non-polar that best to dissolve in the non-polar solvent. Second factor, that is a temperature in a nearly saturated solution, the dissolution process that is a endothermic in nature. Many of cases the saturated solution the dissolution process वो की होती है एक endothermic है, endothermic ਦੇ ਵਿੱਚ that need heat, means enthalpy of solution that is greater than 0, and solubility should increase with the rise in temperature. ठीक है. with rise in temperature, जिदा temperature ਆਪਾਂ rise ਕਰਾਂਗੇ ਉਹਦੇ ਨਾਲ ਕੀ ਆ ਉਹਦੇ ਵਿੱਚ dissolving ਦੀ capacity ਜਿਹੜੀ ਹੈ ਉਹ ਜ਼ਿਆਦਾ ਵੱਧ ਜਾਏਗੀ. so if the process is exothermic, ਜਿਹੜੇ exothermic ਹੈ ਜੇਕਰ heat ਉਹ 'ਚ less than 0 enthalpy of solution less than 0, the solubility should decrease, ਤਾਂ ਉਸ ਟਾਈਮ ਕਹਿੰਦਾ solubility ਕੀ ਹੈ ਉਹ decrease ਕਰਿਆ ਕਰੇਗੀ. ठीक है. so next है solubility of gases in liquid decrease with the rise in temperature. जिस तरह temperature rise करांगे solubility ਜਿਹੜੀ gases in liquid है that is decreases हो जाएगी. ठीक है. and when dissolve the gases molecule are present in the liquid phase, the process of dissolution that is exothermic in nature. therefore solubility should decrease with the increase in temperature. तो ਉਹਦੇ ਨਾਲ ਕੀ solubility ਕੀ ਕਰ ਜਾਂਦੀ ਹੈ decrease ਕਰ ਜਾਂਦੀ with the increase in temperature. next that is a pressure term. So pressure that is does not have significant effect on the solubility of a solid in liquids. ठीक है. because solid and liquid has a highly incompressible. ठीक है. solid ਤੇ liquid ਦੇ ਉੱਤੇ pressure ਦਾ effect ਹੈ ਉਹ negligence ਦੇ amount ਦੇ ਵਿੱਚ ਹੁੰਦਾ. ठीक है. practically remain unaffected by changes in pressure. ठीक है. next what is the question आ ਜਾਂਦਾ reasoning ਦੇ ਵਿੱਚ aquatic life is more comfortable in cold water than warm water. so this is due to the that is solubility of gases similar especially the solubility of oxygen gas. so as we know in the cold water that is the temperature is when temperature is low the solubility will become high. so at a temperature in the cold water that will have more oxygen dissolve, more pressure, more air pressure air are present, मतलब mean more dissolve oxygen are present than warm water. so aquatic life more comfortably behave in cold water. Next, the solubility of gas in liquid. So that can be explained on the Henry's law. So Henry law is, that is a, the law states that at a constant temperature the solubility of gas in liquid, solubility of gas in liquid, that directly proportional to the pressure of a gas. Second definition, it also states that the mole fraction of gas in the solution is proportional to the partial pressure of gas over the solution, or the partial pressure of a gas in a vapor phase, that is proportional to the mole fraction of a gas in the solution. मतलब vapor pressure of solution that is directly proportional to the mole fraction of gas. अगर proportionality constant हटावांगे that will give the proportionality constant kh, which is known as the Henry law constant. ठीक है. सो ग्राफिकल रिप्रेजेंटेशन अगर देखिए, क्योंकि प्रेशर ऑफ ए गैस दैट इज डायरेक्टली प्रोपोर्शनल टू मोल फ्रैक्शन है. सो प्रोपोर्शनल है डायरेक्टली द, सो ग्राफ इज ऑल्सो स्ट्रेट लाइन. प्रोपोर्शनलिटी कॉन्स्टेंट हटावांगे दैट विल गिव के एच इज हेनरी लो कॉन्स्टेंट कह देंगे अपन. ठीक है. स्लोप ऑफ ग्राफ दैट इज हेनरी लो कॉन्स्टेंट. Next, the characteristics of KH, that is a Henry law constant. So different gases have different KH values at the same temperature. This suggests that KH is a function of the nature of the gas. So at nitrogen 293, that will KH value is 76, and oxygen at 293, that is the KH is 34. So higher the value of KH, lower is the solubility उतनी घट होगी. ठीक है. So this is the main fundamental phenomena that is a basis on KH value. So this is one of the most important topic from which many questions are asking again and again. So next one is, so for example, the solubility of gases increase with the decrease in temperature. So as we know, 293 Kelvin KH 76 है, 303 Kelvin है 88 है, 293 है that is a 34 है, 303 नाइट्रोजन that will KH value 46 है. ठीक है. अलग अलग वैल्यू आ रही है KH. Next, that is the application of a Henry law. So first application, that is in packing of soda cans. आप डेली देखते हैं सोडा वाटर बोटल्स. ठीक है. जिन्हें भी कोल्ड ड्रिंक बोतल है और कार्बोनेटेड ड्रिंक आर बोटल अंडर है हाई प्रेशर टू इंक्रीज द solubility of carbon dioxide solution in the solution. So when bottle is open, the pressure above the solution decreases and some of carbon dioxide bubble and released off, which leads to a effervescence or phase. ठीक है. सो ਇਹਦੇ ਵਿੱਚ ਦੇਖਦੇ ਹਾਂ ਜਿੰਨੀ ਮੈਕਸਿਮਮ ਕੋਲਡ ਡਰਿੰਕ ਬੋਟਲਸ ਹੈ ਕਾਰਬੋਨੇਟਡ ਡਰਿੰਕ ਵਾਟਰ ਹੈ ਉਹਨਾਂ ਦੇ ਵਿੱਚ ਸੋਲੂਬਿਲਿਟੀ ਜਿਹੜੀ ਹੈ ਕਾਰਬਨ ਡਾਈਆਕਸਾਈਡ ਸੋਲੂਸ਼ਨ ਦੀ वो ज़्यादा होती है ड्यू टू द प्रेशर. So next one, that is in deep sea diving. So when scuba divers come toward the surface of water, the pressure gradually decreases. So this release the dissolved gases and leads to formation of bubble in the nitrogen in the blood and blocks the capillary and create a medical condition and known as the vents. So as we know, in the earth, as the earth, above the earth and below the earth, that is sea water. as a sea, that is a 1 atmospheric pressure normal है. So जिस तरह above the surface जाने तो pressure decrease करता है. ठीक है. pressure decrease करता है जितना नीचे जाने ਆਪਾਂ ਸਮੁੰਦਰ ਵਿੱਚ pressure increase ਕਰ ਰਿਹਾ ਉੱਥੇ. ਠੀਕ ਹੈ. ਜਦੋਂ pressure increase ਕਰਦਾ ਪਿਆ. ਸੋ ਜਿੱਦਾਂ ਹੀ ਸਕੂਬਾ ਡਾਈਵਰਸ ਹੈ ਉਹ ਨੀਚੇ ਜਾਂਦੇ ਹੈਗੇ ਆ ਕਮ ਟੂ ਵਾਟ, ਤਾਂ ਉਹ ਨੀਚੇ ਤੋਂ ਬਾਅਦ ਵਿੱਚ ਜਦੋਂ ਉੱਪਰ ਨੂੰ ਆਉਣਾ ਕਮ ਬੈਕ ਟੂ ਵਾਟ ਦਾ ਸਰਫੇਸ 'ਤੇ ਵਾਪਸ ਆਉਂਦੇ ਆ. ਤਾਂ ਉਸ ਸਰਫੇਸ 'ਤੇ ਆਉਂਦੇ ਕੀ ਹੁੰਦਾ ਕਿ ਜਿਹੜਾ ਉਹਦੇ ਵਿੱਚ ਦੇ ਕੈਰੀ ਦਾ ਆਕਸੀਜਨ ਗੈਸਿਸ ਸਿਲੰਡਰ, ਜਦੋਂ ਉਹਨਾਂ ਦੀ ਬੋਡੀ ਦੇ ਵਿੱਚ ਉਹ ਆਕਸੀਜਨ ਜਿਹੜੀ ਹੈ ਬਲੱਡ ਦੇ ਵਿੱਚ ਜਾਂਦੀ ਹੈ, ਦੈਟ ਵਿਲ ਕ੍ਰੀਏਟ ਸਮ ਪ੍ਰੋਬਲਮ. The reason is that the pressure. So as we know, in the below surface, that is the pressure is high in the water level, and when they come toward the surface level, pressure started decreasing. So due to that, the releases of dissolved gases and lead to formation of bubble and nitrogen in the blood. So due to that, there is a creation of a problem in the pressure. So due to that, the capillaries and medical condition that like bends are occur, and maybe heart attack condition or attacking condition takes place. So to avoid these bends and tank use scuba diver is filled air and diluted with, so air is filled with the diluted, that is a helium 11.7% or helium 56.2%, nitrogen helium 11.7%, helium 52.2%, 56.2% that is a nitrogen, and 32.1% oxygen. So that can be diluted with the helium, nitrogen and oxygen gases. Due to that, so the pressure does not affect on the capillaries of the scuba divers, so that they can easily survive and come back on the surface. So third application for the climbers of people living at high altitude. As we know, at the high altitude pressure is very small, or pressure decreases. So for climbers and people living at high altitude, the concentration of oxygen, as we know, as we move along the high altitude, that the pressure start decreasing, and also the oxygen level also start decreasing. So due to that, the concentration of oxygen in blood and the tissue is low. So due to this, climber become weak and unable to think clearly, because the oxygen flow in the blood started decreasing, and this leads to the condition that is a anoxia. So this is the example. Next, that is the fishes and other aquatic life that is survive inside the water bodies in polar areas where water freezes on the top. So reason is that when the temperature of atmosphere falls below the 4 degrees centigrade, the water at the surface gradually freezes to the ice, but the water under the ice, that is remain at 4 degrees centigrade. So at temperature near about 4 degrees centigrade, their aquatic life may be easily survive. Next, that is a thermal power plants that discharge the hot water into the water bodies like ponds, rivers and lakes, and may kill the fishes by decreasing the dissolved oxygen concentration. That will also affect the concentration of dissolved oxygen. Next, a vapor pressure of a liquid solution. So vapor pressure, so it is the pressure exerted by vapor above the liquid surface in the equilibrium with the liquid at a given temperature, that is called as a vapor pressure. So again, the pressure exerted by the vapors above the liquid surface. ठीक है, liquid है ਉਹਦੇ पर जितना भी vapor बन गया, that is a, due to that the pressure is at 12, that is known as the vapor pressure. So vapor pressure of a liquid solution, that can be shown with the Rolle's law. So Rolle's law states that for a solution of a volatile liquid, the partial vapor pressure of each volatile component in a solution, that is directly proportional to the mole fraction. So consider a binary solution of two volatile liquids A and B. So if PA and PB, the partial pressure of vapor pressure of two liquids XA and XB, will the mole fraction of two solutions. So according to Rolle's law, PA partial pressure become equal to partial pressure of component in pure state, PA naught multiple XA. Similarly, for B component, PB become equal to PB naught into XB. So where PA and PB are the vapor pressure of the pure components A and B respectively. So similarly, in the graphical representation, when we draw graph between the vapor pressure and mole fraction for the component 1 and 2 component, so here x1 equal to 1, so x2 mole fraction of B component becomes 0. So here is the vapor pressure first component, similarly second component, so mole fraction is 1, so first component is 0, so the partial pressure ये वाला हो जाएगा. So इधर with respect to दोनों दी कर्व पर ड्रा करेंगे, total vapor pressure become equal to PA P1 plus P2. So Rolle's law in combination with the Dalton law of partial pressure. So assuming that vapor pressure of a liquid that is behave like an ideal gas, so then according to Dalton law of partial pressure, so PT can be given as if PT, that total vapor pressure become equal to partial pressure of A component plus partial pressure of B component. So as we know, according to Rolle's law, that is PA become equal to PA naught into XA and PB become equal to PB naught into XB. So as we know, the XA plus XB become equal to 1. So put the value of XA from here to the first equation, so this equation, so PT will give this relationship. Further solving, that will give this relationship. So Rolle's law, that is a special case of Henry's law. So this is a special case. So only the proportionality constant, that is the KH, differ from जिस तरह आप देखते हैं कि Henry law ते Rolle's law. According to Rolle's law, partial pressure of any component become equal to partial pressure of any component in pure state multiple mole fraction, and according to Henry law, vapor pressure of any substance that is directly proportional to the mole fraction, and proportionality sign हटा देना, the kh that is a Henry law constant. So here the only proportionality constant kh that is a differ from Pa naught, therefore Rolle's law become a special case of Henry's law. So next one, that is the classification of a binary solution. There are two types of solution, that is the ideal and a non-ideal solution. The ideal solution, the solution which obey Rolle's law exactly at all concentration and all temperature, that is called as the ideal solution. Let Pa and Pb are the partial vapor pressure of Xa and Xb are the mole fraction of these volatile components A and P respectively. Then according to Rolle's law, we can write as Pa equal to Pa naught into Xa, Pb become equal to Pb naught into Xb. So according to Dalton law of partial pressure, total vapor pressure that is given as Pa equal to Pa plus Pb, that is P become equal to Pa naught Xa plus Pb naught plus into Xb. ठीक है. So graphical representation of an ideal gas can be shown here. An ideal solution is a solution which obey Rolle's law at all concentration and temperature. The essential characteristics of ideal solution are that obey Rolle's law at all concentration and temperature, where delta H mixing 0, delta V mixing become equal to 0. So graphically that can be shown as vapor pressure, mole fraction, first component and second component. ठीक है. A component 1 थे ਤੇ B ਕੰਪੋਨੈਂਟ ਫਸਟ ਹੈ. 1 ਵੈਲਿਊ ਅਗਰ ਪੁੱਟ ਕਰਦੇ ਹਾਂ ਆਪਾਂ ਇਨ ਦਾ ਇਕੁਏਸ਼ਨ, that is a P total equal to PA plus PB. ਸੋ PA ਤੇ PB ਜਦੋਂ ਵੈਲਿਊ ਪੁੱਟ ਕਰਦੇ ਹਾਂ ਟਰਨ ਬਾਈ ਟਰਨ, ਸੋ ਇਹਦੇ ਵਿੱਚ PA become equal to PA naught XA. ਸੋ ਜਦੋਂ XA 1 ਹੈ, ਸੋ PA become equal to PA naught ਹੋ ਜਾਏਗਾ. ਸੋ ਇੱਥੇ ਚਲੇ ਜਾਏਗੀ ਵੈਲਿਊ. ਸਿਮਿਲਰਲੀ ਜਦੋਂ ਐਕਸ ਵੀ 1 ਹੋ ਜਾਏਗਾ ਬੀ ਕੰਪੋਨੈਂਟ ਲਈ ਤਾਂ ਪੀ ਬੀ ਨੋਟ ਹੋ ਜਾਏਗਾ. ਸੋ ਇਹਦੇ ਅਕੋਰਡਿੰਗ ਆਪਾਂ ਗ੍ਰਾਫ ਡਰਾ ਕਰਾਂਗੇ. ਸੋ ਟੋਟਲ ਵੇਪਰ ਪ੍ਰੈਸ਼ਰ ਬਿਕਮ ਇਕੁਅਲ ਟੂ ਪੀ ਏ ਪਲੱਸ ਪੀ ਬੀ. ਠੀਕ ਹੈ. ਸਿਮਿਲਰਲੀ ਫॉर द नॉन आइडियल solution, the solution which do not obey Rolle's law at all concentration and temperature, that is called as a non-ideal solution. And for a non-ideal solution, that is a PA not equal to PA naught into XA, and similarly PB not equal to PB naught into XB. So the essential characteristics of non-ideal solution are that does not obey Rolle's law. Second, that is the delta H mixing does not equal to 0, and third, delta V mixing does not equal to 0. ठीक है. So this is the main difference. Next types of non-ideal solution. Non-ideal solution, that is a positive deviation, that show non-ideal solution showing the positive deviation from Rolle's law and show negative deviation from Rolle's law. So first we discuss about the positive deviation from Rolle's law. So in this type, the vapor pressure of each component of the solution, that is greater than vapor pressure as expected by the Rolle's law. So total vapor pressure of solution, that is higher than that of ideal solution for the same composition. So in this solution, delta H mixing and delta V mixing become are positive in nature, greater than 0 value. So here the again vapor pressure A component B component similarly draw करेंगे. So total vapor pressure become above or more than vapor pressure. So ਇਹਦੇ ਲਈ P A ਦੇ ਲਈ ਵੀ higher curve draw होगी, P B ਦੇ ਲਈ ਵੀ and total ਦੇ ਲਈ ਵੀ. ठीक है. So that will give the positive value or give the positive deviation from Rolle's law. Next, main the reason of the positive deviation. Why deviation occur? So in this type, the attraction forces between the solute and the solvent molecule are weaker than. So ਜਦੋਂ ਦੇਖਦੇ ਹਾਂ ਆਪਾਂ A plus B to form AB. ठीक है. So here AA interaction, BB interaction, in the reactant side there is a AB type interaction. So in this attractive forces between solvent and solute, that is a AB interaction are weaker than solute molecule or between the solute. So AB ਜਿਹੜੀ interaction है, that is a less than value AA or BB type interaction. So due to that there is a deviation occur. So it leads to increase in vapor pressure by resulting in a positive deviation. ठीक है. positive deviation occur हो जाती. So example are acetone and carbon disulfide, benzene and toluene, and ether and acetone. These are the example of deviation. Second, a negative deviation. In this, both the components are having the partial pressure less than that of Rolle's law, and here the AB type of interaction, that is a greater than AA or BB type interaction, ठीक है. So as a result, total vapor pressure of solution that is lower than that of ideal solution at the same composition. So that's why delta H mixing and delta V mixing are negative in nature. So this is a graphical representation ਜਿਹਦੇ ਵਿੱਚ ਕੀ ਹੈ ਵੈਲਿਊ ਘੱਟ ਹੋਏਗੀ ਤਾਂ total vapor pressure less than, ठीक है. इस तरह नेगेटिव वैल्यू नेगेटिव डेविएशन शो करेंगे. So cause of negative deviation, it is also due to the there is a solute solvent interaction, that is a AB type interaction, that is a greater than the AA or BB type interaction. So due to that will show resulting in the negative deviation and vapor pressure started decreasing. So example, benzene chloroform and nitric acid chloroform and ether. So this is the example, that is the cause of negative deviation. Next, that is the azeotropes. Azeotrope, that is also a most important topic. The solution which boil at a constant temperature. The solution which boil at a constant temperature, that is called as a azeotrope, and can distill over a completely at the same temperature without change in any composition, that having the constant boiling mixture, that are also known as the azeotrope. The solution which boil at a constant temperature and distill over completely at the same temperature without any change in composition, that is constant boiling mixture. So azeotrope दो तरह के होंगे, they are minimum boiling azeotrope and maximum boiling azeotrope. The solution that show large positive deviation from Rolle's law, that is called as a minimum boiling azeotopes, ठीक है. And here the 95.6% ethanol and 4.4% water by volume, ठीक है. So this is that is a minimum boiling azeotrope that will show positive deviation. Next, that is a maximum boiling azeotrope, that is the solution that show large negative deviation from Rolle's law, that is a maximum boiling azeotrope. Here 21.2% HCl and 78.8% water by weight, or 68% nitric acid and 32% water by mass, ठीक है. These are the example. Next, main important topic of this chapter, that is the colligative properties. There are 4 colligative properties which are in our topic, so that are most important. So let's start with the colligative properties. The properties of the solution which depend only on the number of solute particle and not on the nature of solute particle, that are called as the colligative property. This is the most important definition. The properties whose value depend upon the number of solute particle. Number of solute particle and nature that depend करते हैं. So there are 4 colligative properties. That is the first, relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So these are the 4 colligative properties, ठीक है. So let's start from the first, that is a relative lowering in vapor pressure. So vapor pressure is the escaping tendency of the liquid from the surface of solution. So vapor pressure, that is excess pressure which must be applied to the solution side to prevent the evaporation. So that is a vapor. So in the solution, a part of a liquid surface that is occupied by a non-volatile solute particle, ठीक है. Therefore the evaporation of a liquid will takes place from a lesser surface, and this is referred to as a lowering of vapor pressure. So ਜਦੋਂ ਵੀ ਕੋਈ ਵੀ ਸਾਡੇ ਕੋਲ ਸੋਲੂਸ਼ਨ ਹੈ ਉਹਨੂੰ ਆਪਾਂ ਹੀਟਿੰਗ ਕਰਾਂਗੇ, that will create a vapor. Due to that the pressure exerted at that surface, that is called as a vapor pressure. So if we add the non-volatile solute, that will decrease the vapor pressure. So due to that evaporation of liquid will takes place at a lesser surface. So this is referred to as a lowering of vapor pressure. So ਉਹਦੇ ਨਾਲ ਕੀ ਹੋ ਜਾਏਗਾ, vapor pressure lower ਹੋ ਜਾਏਗਾ, that is called as a lowering of vapor pressure. So according to Rolle's law, the relative lowering of vapor pressure of a solution that will become equal to the mole fraction of non-volatile solute. So for a component partial, according to Rolle's law, Pa become equal to Pa naught into Xa. So as we know, Xa become equal to 1 minus Xv value. So put the value here, we will get a Pa equal to Pa naught 1 minus Xv. So इत्थों ਆਪਾਂ Pa over P naught into 1 minus Xv एक साइड कर दिंदे हैं. So subtracted 1 from both sides, so we will get the value of Xb, that will become equal to Pa naught minus Pa over Pa naught, ठीक है. So that is here Pa naught minus Pa become equal to PA naught into XV, that is it show that the PA naught minus PA, that is a lowering of a vapor pressure, that is directly proportional to the mole fraction of the solute. So any property which show that is depend upon the number of a solute particle or a mole fraction of the solute, that will show that will exist as a colligative property. So this is called as a lowering of vapor pressure. So when we divide PA naught minus PA over PA, so this is called as a relative lowering of vapor pressure. ठीक है जी. So hence it is a colligative property. Next the second part, that is a determination of molar mass. So according to Rolle's law, a relative lowering of vapor pressure that will become equal to mole fraction of solute. So PA naught minus PA over PA naught become equal to XP. So as we know, XP mole fraction of solute become equal to number of moles of solute divided by total number of moles, Na plus Nb. So number of moles of a component given mass over molar mass of solvent, number of moles of solute given mass of solute over molar mass of solute. So for a very dilute solution, Nv very less than Na, so Xv become equal to Nb over Na plus Nb, also become equal to Nb over Na when value of Nv number of moles of solute become very less than Na. ठीक है. सो इतों आप जो सॉल्व करा XV वैल्यू साढ़े को आ जाएगी, दैट इज ए WB ओवर MB मल्टीपल MA ओवर WA. ठीक है. सो ये वाली वैल्यू जो पुट करा इतने मोल फ्रैक्शन के, सो पार्शल रिलेटिव लोअरिंग ऑफ वेपर प्रेशर बिकम इक्वल टू WB ओवर MB MA ओवर WA. सो MA मोलिकुलर मास ऑफ सल्यूट, MB मोलिकुलर मास ऑफ सल्यूट. सो MB की इतों कैलकुलेट निकाल लवेंगे. सो दैट विल गिव द रिलेशनशिप बिटवीन द मोलिकुलर मास ऑफ द सल्यूट डिटर्मिनेशन फ्रॉम द रिलेटिव लोअरिंग ऑफ वेपर प्रेशर, दैट इज फ्रॉम द फर्स्ट कोलिगेटिव प्रॉपर्टी. ठीक है. सो सेकंड कोलिगेटिव प्रॉपर्टी, दैट इज ए एलिवेशन ऑफ बॉइलिंग पॉइंट. ठीक है. द एलिवेशन ऑफ बॉइलिंग पॉइंट ऑफ अ लिक्विड, दैट इज डिफाइंड एज द टेम्परेचर एट विच वेपर प्रेशर ऑफ अ लिक्विड बिकम इक्वल टू एटमोसफेरिक प्रेशर. किसी भी लिक्विड का जगह वेपर प्रेशर है एट टेम्परेचर, वेपर प्रेशर जो भी एटमोसफेरिक प्रेशर के इक्वल हो जाएगा, दैट इज कॉल्ड एज ए बॉइलिंग पॉइंट. अदों ही कोई भी सोल्यूशन की है बॉयल करना स्टार्ट करता है. सो लेट द बॉइलिंग पॉइंट ऑफ सोल्यूशन, दैट इज ए TB containing a non-volatile solute. अगर non-volatile solute है, that again that is started decreasing the formation of vapor. So non-volatile solute is always greater than that of pure solvent TB naught. So the effect of adding a non-volatile solute on boiling point and the vapor pressure, that is a represent graphically. So here we can see that in the graphical representation of vapor pressure become with the temperature. So first curve with the boiling point of a solvent, that is this one, atmospheric pressure. So with respect to that is a solvent, that is a TB naught is the boiling point of pure solvent. ठीक है. So upon adding the solute, that is a non volatile solute. ठीक है. So that will give the curve, solution curve. So this is the temperature, that is a TB boiling point temperature of the solution by adding the solute particle. So in the graph TB naught, that is vapor pressure of solution, that is a less than that of vapor pressure of pure solvent. ठीक है. उधर नालों घट है. So therefore the solution does not boil at a TB naught. ठीक है. इस करके solution TB naught ते जिहड़ा हैगा वो boil नहीं करेगा. So but it boil at elevated temperature, but boil करेगा जदों temperature elevate करांगे. So where the vapor pressure of solution become equal to atmospheric pressure, then water start boiling. So difference between the boiling point of a solution, that is a TB, and that of a solvent TB naught, that is called as a elevation in boiling point, that is denoted by delta TB. So this is the main difference, that is a delta TB. The difference है दोनों दे विचकार, that is called as a elevation in a boiling point. Okay, which help to make the 1 atmospheric pressure. So as we note that so change in elevation boiling point, that delta TB become equal to TB minus TB naught. So it is found that the elevation of boiling point, that is directly proportional to the number of moles of solute in a given amount of solvent. so that is directly dependent upon the number of moles of solute. So delta TB, that is directly proportional to the small m, that is a molality, number of moles of solute. So upon proportionality constant removal, that is delta TB become equal to Kb into m, and Kb that is called as a abelioscopic constant or molar elevation constant. मोलर एलिवेशन कांस्टेंट कह दें आप इनू, ठीक है, अबिलियोस्कोपिक कांस्टेंट मोलर एलिवेशन कांस्टेंट. सो डेल्टा टीबी बिकम इक्वल टू केबी व्हेन मोलरिटी बिकम इक्वल टू यूनिटी. So molar elevation constant or abelioscopic constant. So what is Kb? So Kb that is called as a molar elevation constant or abelioscopic constant, and it is defined as the elevation of boiling point produced by dissolution of 1 mole of non-volatile solute in 1000 gram of solvent. ठीक है. Next that is the application. So elevation boiling point the application की है, that is a sea water freeze at low temperature. sea water देखते पे freeze करता लो temperature, then distilled water but boil at high temperature. ठीक है, distilled water ਜਿਹੜਾ boil करेगा high temperature ਤੇ. sea water contain dissolved salt and therefore boiling point increases and freezing point decreases. sea water ਜਿਹੜਾ ਹੈਗਾ contain dissolved salt, ਉਹ 'ਚ dissolved salt ਹੁੰਦੇ ਆ and therefore boiling point ਇਸ ਕਰਕੇ increase ਕਰ ਜਾਂਦਾ and freezing point decrease ਕਰ ਜਾਂਦਾ. On the next that is the addition of a coolant. addition of coolant ਜਿਹੜਾ azeotropic mixture ਆਪਾਂ ਗਿਆ ਹੈਗਾ, that is the addition of a coolant help to raise the boiling point of the water to prevent the radiator from overheating. ਰੇਡੀਏਟਰ ਨੂੰ ਓਵਰਹੀਟਿੰਗ ਕਰਨ ਤੋਂ ਬਚਾਉਣ ਦੇ ਲਈ ਰੇਜ਼ ਕਰਦਾ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ, ਇਸ ਕਰਕੇ ਐਡੀਸ਼ਨ ਆਫ ਕੂਲੈਂਟ ਵਿਲ ਹੈਲਪ ਕਰਦੇ ਹਾਂ ਆਪਾਂ. ਠੀਕ ਹੈ. ਰਿਫਾਈਨਿੰਗ ਆਫ sugar from the sugar cane solution, that is also application of elevation boiling point. Next that is the second part, determination of molar mass. So a known mass of solute is dissolved, that is known as the mass of solvent. So as we know, delta TB become equal to Kb into molality. So as we know definition of molality, it is defined as a number of moles of solute dissolved in mass of solvent in gram multiple by 1000. So put करेंगे वैल्यू सारी, ठीक है, that is number of moles, molality Wb और Mb 1000 over Wa. so ये सारी वैल्यू पुट करेंगे. delta TB साढ़े को आ रहा है Kb into Wb मल्टीपल 1000 over Mb मल्टीपल Wa, तो इतों आप Mb की वैल्यू पर निकाल पावेंगे. ठीक है, molecular mass. So this is the easily determination method. So next that is the application. To get a hard boil egg, ਜਦੋਂ ਵੀ ਆਪਾਂ ਦੇਖਦੇ ਹਾਂ boil egg ਕਰਦੇ ਹਾਂ ਤਾਂ sodium chloride is added to the water. ਕਈ ਵਾਰ ਸੋਡੀਅਮ ਕਲੋਰਾਈਡ ਵੀ ਕੀ ਹੈ ਕਿ ਸੋਡੀਅਮ ਕਲੋਰਾਈਡ ਉਹਦੇ ਵਿੱਚ ਐਡ ਕਰਦੇ ਆ ਤਾਂ ਕਿ ਬੋਇਲਿੰਗ ਪੁਆਇੰਟ ਰੇਜ਼ ਹੋ ਜਾਏ, ਤਾਂ ਉਹਦਾ ਜਿਹੜਾ ਹਾਰਡ ਸ਼ੈਲ ਹੈ, ਆਊਟਰ ਸਾਈਡ ਸ਼ੈਲ ਹੈ, ਉਹ ਆਊਟ ਹੋ ਜਾਏ. Next addition of a salt or a non-volatile solid reduce the vapor pressure of the liquid and consequently the boiling point increases and the water can attain a temperature higher than that of 100 degree centigrade before starting to boil. ठीक है. Next है this help to cook and hard boil egg. कुकर ਇਹਦੇ ਕਰਕੇ ਜਿਹੜੇ ਹੈਗੇ ਕੁੱਕ ਕਰ ਜਾਣਗੇ ਐਗ ਵਗੈਰਾ. The addition of a salt to water before or while heating will increase its boiling point, and boiling point बढ़ जाएगा. So for example numerical problems. So on dissolving 10.8 gram glucose, molar mass is given here, into 40 gram of water, the boiling point increases by 0.13 degree centigrade. Calculate molar elevation constant. So delta TB सानू देता है, WA भी देता है, MB भी देता है, WB भी देता है. So delta TB become equal to formula KB into WB over MB, WA into 1000. So इत्थों KB आउट करके बाकी सारे दी वैल्यू पुट करांगे, सॉल्व करांगे, विल गिव द वैल्यू ऑफ KB, abelioscopic constant या molar elevation constant. Second numerical, solution of 2.5 gram of, that is a non-volatile solute in 100 gram of benzene boiled at 0.4 degree centigrade, 4 to degree centigrade, higher than that of boiling point of pure benzene. Calculate molecular mass of substance. Molar elevation constant of benzene, that is given here, KB is here, WB is given, WA, delta TB. सो इत्थों अगेन आप MB निकालांगे, फॉर्मूले ਦੇ ਵਿੱਚੋਂ ਸਾਰਿਆਂ ਦੀ वैल्यू पुट करांगे, तो सो मोलिकुलर मास हमें मिल जाएगी 158.9 ग्राम पर मोल. ठीक है. सो नेक्स्ट सिमिलरली द मोलर एलिवेशन कांस्टेंट फॉर वाटर, KB वैल्यू गिवन है सानू. कैलकुलेट बॉइलिंग पॉइंट ऑफ सोल्यूशन. ठीक है. TB आप कैलकुलेट करांगे. solution by dissolving 6 gram of urea. ठीक है, given mass WB भी सानू given है 6 gram urea into 100 gram WA given है 200 gram molar mass MB that is 60. So as we know formula delta TB equal to KB into WB over MB 1000 over WA. So delta TB वैल्यू सारी पुट करांगे सोल्व करांगे that is delta TB. So now the boiling point of solution that is the boiling point of water plus delta TB. So that will give 100 degree plus 0.28 degree centigrade will give the 100.28 degree centigrade. So this is the solution. So next third qualitative property that is the depression of a freezing point. So the freezing point of a liquid is defined as the temperature at which a liquid and solid state of a substance have the same vapor pressure. Solid again, liquid and solid surface states have same vapor pressure. The freezing point of solution that is a TF and non containing a non-volatile solute is always less than that of a pure solvent TF note. Okay. So freezing point solution that is always less than that of pure solvent because by addition of a non-volatile solute that also started decreasing the vapor pressure. So the effect of adding a non-volatile solute on the freezing point and vapor pressure that is represented again graphically. It is shown here. So as we know, as a liquid solvent that is having the TB value TF value here, TF node and higher vapor pressure respectively. ठीक है, and by adding non-volatile solute that is a solution that is a solid changes into liquid frozen state. This is a frozen state and a solution. This is a TF that is in boiling freezing point of solution. So that will show decrease in vapor pressure. So from this graph that is a TF node, the vapor pressure of solution is less than vapor pressure of pure solvent. So therefore the solution does not freeze at a TF node. So it freezes at a depressed temperature TF where the vapor pressure of solution become equal to atmospheric pressure. So that will start a freezes at a temperature when vapor pressure of solution become equal to atmospheric pressure. The difference in freezing point between the pure state TF node and TF that is called as a depression in freezing point denoted by delta TF. ठीक है, so delta TF become equal to TF node minus TF. So for a dilute solution, the mole fraction of a solute that is directly proportional to the molality of a solution. So it can be written here, and upon removing the proportionality constant that will give the Kf, and Kf that is called as a cryoscopic constant or molar freezing constant. So delta TF become equal to Kf when molarity is unity. So molar that is a Kf can be known as a molar depression constant or cryoscopic constant. So molar depression constant or cryoscopic constant, it is defined as a depression of freezing point produced by dissolution of 1 mole of solute in 1000 gram of a solvent. So since delta TF that is a proportional to the molality and delta TF is a colligative property. As we know the definition of a colligative property that depend upon the number of solute particle. So a non-mass of solute that dissolve in a non-mass of solvent and freezing point depression delta TF is determined as here delta TF is equal to Kf into molality. So molality that is the number of moles of solute over mass of solvent multiple by 1000 that is WB over MP multiple 1000 over WA. So put करेंगे value. So delta TF ਦਾ ਰਿਲੇਸ਼ਨਸ਼ਿਪ ਇੱਥੋਂ ਆਪਾਂ MB ਦਾ ਕੈਲਕੂਲੇਟ ਕਰ ਲਵਾਂਗੇ molecular mass determination from the depression in freezing point. So next that is the application in cold climate. Ethylene glycol is added to water in car radiator as antifreeze. Antifreezing agent ਆਪਾਂ ਕੂਲੈਂਟ ਦੇ ਤੌਰ ਤੇ ਜਿਸ ਤਰ੍ਹਾਂ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ ਆਪਾਂ ਕੋਲਡ ਕਲਾਈਮੇਟ ਦੇ ਵਿੱਚ ਇਥਾਈਲਿਨ ਗਲਾਈਕੋਲ ਉਹਦੇ ਐਡ ਕੀਤਾ ਜਾਂਦਾ ਵਾਟਰ ਦੇ ਵਿੱਚ. ਸੋ ਡਿਊਰਿੰਗ ਵਿੰਟਰ ਸਾਲਟ ਇਜ਼ sprinkled on the road to lower the freezing point. ਸੋ ਜਿਹਦੇ ਵਿੱਚ ਕੀ ਦੇਖਦੇ ਹਾਂ ਆਪਾਂ ਕਿ ਕਈ ਵਾਰ ਵਿੰਟਰ ਦੇ ਸਰਦੀਆਂ 'ਚ ਬਰਫ਼ ਜ਼ਿਆਦਾ ਪੈ ਜਾਂਦੀ ਰੋਡ ਦੇ ਉੱਤੇ ਤਾਂ ਉਹਦੇ ਉੱਤੇ ਸਾਲਟ ਪਾਇਆ ਜਾਂਦਾ ਤਾਂ ਕਿ ਕੀ ਹੈ freezing point low ਹੋ ਜਾਵੇ ਉਹਦਾ. So sea water freezes at low temperature than distilled water and sea water contain dissolved salt, therefore boiling point increase and freezing point decreases. So next is the problem based upon freezing point. So on dissolving 0.25 gram of a non-volatile substance at 30 ml benzene, its freezing point decreases by 0.40 degrees centigrade. Calculate molecular mass of non-volatile substance. So Kf is value is here 5.12 Kelvin kg per mole. Wv भी given है, delta Tf भी given है, and mass of benzene become equal to, that is the density, the formula density equal to mass per unit volume. ठीक है, इतों mass निकाल लवांगे, that is volume into density. सो सॉल्व करांगे. नैक्सट दैट इज़ ए फॉर्मूला ऑफ एम पी डेल्टा टी एफ के नाल रिलेशनशिप. सो आप एम पी इतों कैलकुलेट कर लाँगे सारे की वैल्यू इतने पुट करके. ठीक है, दैट विल गिव द मॉलिकुलर मास. नेक्स्ट सिमिलर क्वेश्चन, दैट इज बाय डिसॉल्विंग 13.6 ग्राम ऑफ सबस्टेंस इन 20 ग्राम ऑफ वाटर, द फ्रीजिंग पॉइंट डिक्रीज्ड बाय 3.7 डिग्री. कैलकुलेट मॉलिकुलर मास. सो के एफ गिवन है, डब्ल्यू बी गिवन है, डब्ल्यू ए गिवन है, डेल्टा टी एफ गिवन है, एम पी कैलकुलेट करनी अगेन बाय यूजिंग फॉर्मूला. पुट करांगे सारे की वैल्यू सॉल्व करांगे. ठीक है, नेक्स्ट है ऑस्मोसिस एंड ऑस्मोटिक प्रेशर. दैट नेक्स्ट टॉपिक, दैट इज ए फोर्थ कोलिगेटिव प्रॉपर्टी, दैट इज ए ऑस्मोटिक प्रेशर. सो बिफोर ऑस्मोटिक प्रेशर, osmosis is the phenomena, that is a phenomena of a spontaneous flow of a solvent through a semi permeable membrane from a pure solvent to the solution, that is called as a osmosis, or from a dilute solution to the concentrated solution, that is called as a osmosis. ठीक है, the spontaneous flow of a solvent from a semi permeable through a semi permeable membrane from a pure solvent to the solution. So osmotic pressure, the excess pressure which must be applied to the solution to prevent the flow of a solvent from its side to solution across a semi permeable membrane, that is called as a osmotic pressure. सो ये की है कि जो भी कि आप देखिए कि अगर फ्लो इस तो इतों इधर जा रहा है फ्रॉम डाइल्यूट सोल्यूशन टू कंसनट्रेटेड सोल्यूशन थ्रू ए सैमी परमीबल मैम्ब्रेन. सो इस साइड तो एक्सेस प्रेशर जेकर आप अप्लाई करते हैं कि जिन्ना भी सोल्यूशन इस साइड में जा रहा वो स्टॉप हो जाए, उत्थे मेनटेन हो जाए. द एक्सेस प्रेशर विच मस्ट बी अप्लाइड ऑन दिस साइड, सोल्यूशन साइड, टू प्रिवेंट द मूवमेंट ऑफ सोलवेंट फ्रॉम वन साइड टू सोल्यूशन through a semi-permeable membrane, that is called as a osmotic pressure. Sorry. Next, what is semi-permeable membrane? A membrane which allows only flow of solvent molecule and not the solute molecule, that is called as a semi-permeable membrane, SPM. ठीक है, semi-permeable membrane. Next, the laws of osmotic pressure. First, that is a want of Boyle's law, what of Charles law. So based upon these applications, so on combining the both two laws, that is a pi, that is the osmotic pressure, that is directly proportional to the concentration term C and temperature T. So upon proportionality constant removing, pi is equal to CRT. R is the gas constant and C concentration, that is equal to the N over V, number of moles over number of moles of solute particle divided by volume term. So that can be written as pi is equal to nRT over V, or pi V equal to nRT. So next, that is the determination of molar mass. So according to what of pi V equal to nRT and N equal to number of moles of solute, that is the given mass of solute over molar mass, W over MB. पुट करांगे वैल्यू इत्थे, दैट विल गिव MB वैल्यू. So molecular mass, the molar mass determination of solute can be done by the osmotic pressure. So determination of molar mass of polymer. So by this method, the molar mass polymer ਦਾ ਉਹ ਵੀ determine कर पाते ਆਪਾਂ. Molecular mass of polymers osmotic pressure is preferred due to the following reason. So ਜਦੋਂ ਵੀ ਕਿਸੇ ਵੀ ਪੋਲੀਮਰ ਜਿਹਦੇ ਵਿੱਚ ਬਹੁਤ ਜ਼ਿਆਦਾ ਯੂਨਿਟਸ ਕੰਬਾਈਨ ਹੈ, ਉਹਨਾਂ ਦਾ ਮੋਲਰ ਮਾਸ ਡਿਟਰਮੀਨੇਸ਼ਨ ਕਰਨਾ ਹੈ, ਤਾਂ ਸਭ ਤੋਂ ਬੈਸਟ ਕੋਲੀਗੇਟਿਵ ਪ੍ਰੋਪਰਟੀ ਦੈਟ ਇਜ਼ osmotic pressure ਨੂੰ ਮੰਨਿਆ ਜਾਂਦਾ. ਦ ਕਾਰਨ, ਦ ਰੀਜ਼ਨ ਇਜ਼ ਦੈਟ poor solubility of the polymers, and polymers are not stable at high temperatures, and osmotic pressure, that is a measurement, can be done at a room temperature easily, and molecular mass can be measured more accurately, and molarity is used instead of the molality. ठीक है. So this is the basic reason. Next is the important definitions are isotonic, hypertonic and hypotonic solution. So that is the two solution having the same osmotic pressure at a given temperature, that is called as the isotonic solution, and a solution of greater osmotic pressure when compared to other solution, that is a hypertonic solution. A solution whose osmotic pressure is less than other solution, that is called as a hypotonic solution. So as we know, in case of a shell, that is the ion concentration in extracellular space that will shrink when hypertonic. The solution having greater osmotic pressure than when compared to other solution. ठीक है, high osmotic pressure, normal that is the same osmotic pressure, ठीक है, and the hypotonic which having the less osmotic pressure, ठीक है, as compared to other. So for intravenous injection, only solution with the osmotic pressure equal to 0.9% NaCl solution is used. Why? सो आप इंट्रावेनियस इंजैक्शन जोड़े भी डॉक्टर लगाते हैं उन्होंने 0.9% NaCl सोल्यूशन यूज करते हैं. सो रीजन इज दैट इज़ आइसोटोनिक विद द ह्यूमन ब्लड दैट हैविंग द सेम ऑस्मोटिक प्रेशर होएगा. दैट इज़ ड्यू टू दैट दीज आर द आइसोटोनिक सोल्यूशन. ठीक है, सेम ऑस्मोटिक प्रेशर होएगा उस सोल्यूशन या उस केमिकल विद द ह्यूमन ब्लड के नाल. सो 0.91% सोल्यूशन दैट इज यूज फॉर इंट्रावेनियस इंजैक्शंस. So yeah, example of osmosis. If we place blood cell in a solution containing more than 0.9% NaCl, अगर solution ਉਹਦੇ ਵਿੱਚ ਕੀ ਕਰਦੇ ਹਾਂ ਆਪਾਂ solution blood cell ਨੂੰ place ਕਰ ਦਿੰਦੇ ਹਾਂ containing 0.9% ਤੋਂ ज़्यादा ਹੈਗਾ NaCl, the water will flow out of the cell. ठीक है, वाटर ਉਹਦੇ ਵਿੱਚੋਂ ਬਾਹਰ आ जाएगा. that will shrink and hypertonic solution बन जाएंगे. ठीक है. And if we place the blood cell in the solution containing less than 0.9% NaCl, then water will flow into the cell and they would swell हो जाएगा. that is a hypotonic बन जाएगा. ठीक है. and if a raw mango placed in concentrated salt solution loses water and via osmosis and shrivel into the pickle, इसे वर्ग ਨੂੰ यूज करते हैं ਆਪਾਂ. ठीक है, वाटर लॉस कर दिंदा. एडिमा दैट इज द रिटेंशन ऑफ वाटर इन इंट्रासैलुलर स्पेस ऑफ पीपल टेकिंग द सॉल्टी फूड ड्यू टू द ऑस्मोसिस. उन्होंने प्रॉब्लम की आ जाती, एडिमा आ जाती जिहड़ी की है टेकिंग साल्टी फूड ज़्यादा ले जाते. वैन ए प्लांट सैल इज प्लेस इन हाइपोटोनिक सोल्यूशन विच प्लेस करते दैन वाटर इज ड्रॉन इन एंड द सेल स्वेल. उसमें सेल स्वेल कर दिंदा. ठीक है. एंड द सेल प्लेस इन हाइपोटोनिक सोल्यूशन जिहदा ज़्यादा osmotic pressure, the water will diffuse out of the cell fluid and partial collapse of the cell will take place. That is a plasmolysis. ठीक है, कह देंगे आप. नेक्स्ट है wilted flowers revive when placed in fresh water. ठीक है, फ्लावर्स देखते फ्रैश वाटर के विच प्लेस करते हैं. ए कैरेट दैट हैज़ बिकम लिम्प बिकॉज ऑफ द वाटर लूजेस इनटू द एटमोसफेयर कैन बी प्लेस्ड इनटू द वाटर मेकिंग it from once again. And people taking a lot of salt or salty food experience water retention in the tissue cell and intracellular space because of the osmosis, due to the osmosis that will occur. ठीक है. Next, that is the reverse osmosis is the brush process. So the direction of osmosis can be reversed by if the pressure larger than that of osmotic pressure is applied to the solution side, that is called as a reverse osmosis. So the pure solvent flows out of the solution through semi-permeable membrane. The phenomena is called as a reverse osmosis. That will reverse osmosis find the application in desalination of seawater and purification of water. घर ਦੇ ਵਿੱਚ RO सिस्टम ਆਪਾਂ यूज़ करते हैं हर एक जगह. दैट इज़ अ रिवर्स ऑस्मोसिस प्रोसैस जिहदे विच सॉल्ट वाटर हुंदा एक्सेस प्रेशर अप्लाई किया जाता सोल्यूशन साइड सो दैट द प्रेशर इज ग्रेटर दैन P. सैमी परमेबल मैम्ब्रेन दे थ्रू सॉल्वेंट मॉलिक्यूल जिहड़े आ फ्लो कर जाएंगे. दैट विल गिव द फ्रैश वाटर एंड वाटर आउटलेट है जिहड़ा कि इम्प्योरिटीज होणगे दैट डज नॉट क्रॉस द सैमी परमेबल मैम्ब्रेन. ठीक है. So application of osmosis, capillary rise in liquid, absorption of water from soil into plants, preservation of meat by salting. ठीक है. Preservation of fruits by adding the sugar. Next, these are the questions based upon the osmotic pressure. Next, that is abnormal molar mass. The wrong value of molar mass obtained from a colligative property due to association or dissociation of molecules, that is called as a abnormal molar mass. ठीक है. So that can be calculated due to association. Association, that is a process in which two or more molecules combine to form bigger molecule. Due to association, there will decrease in the number of particles, and as a result, a decrease in value of colligative property. Hence, observed value of molecular mass will be greater than the normal values. So, for example, dimerization of acetic acid is the acetic acid that will form a dimeric structure, and molecule of ethanoic acid that is dimerized in benzene due to hydrogen bonding, and dimerization occur in solvent with low dielectric constant. Number of particles reduce कर जाएंगे, hence observed value will be greater than the normal value. ठीक है. So similarly, molecule of dimerization of benzoic acid that will happen. ठीक है. Next, abnormal molar mass due to dissociation. If dissociation occur, so I is that is greater than 1, then that is a dissociation. I less than 1, that is association. Dissociation occur, number of solute particle increases, result in the increased value of colligative properties, and hence observed value of molar mass lower than that of normal value. Example, NaCl, KCl, barium chloride, aluminum chloride. For example, as a NaCl that associate into the Na positive and Cl negative ion, number of particles become double, colligative property also double, so molar mass reduced to the half. ठीक है. So example, barium chloride, that is the number of particle, that is a 3 or a 2 plus 1, and a colligative property, that is a triple times, and a molecular mass, that is a reduced by 3 times. ठीक है. Water factor, that is a water factor, it is the ratio of observed colligative property to the theoretical value of colligative property, or ratio of normal molar mass to the observed molar mass. ठीक है. So at that is I can be written as observed colligative property over theoretical colligative property, and then normal molar mass over observed molar mass, that is I can be number of particle after dissociation, association, number of particle before dissociation. Observed colligative property over theoretical colligative property, normal molar mass over observed molar mass. So all the colligative property can be related with the water factor, that is a relative lowering in vapor pressure, that is multiplied by I factor, that is a water factor, if association or dissociation occurs. Similarly, elevation in boiling point colligative property, depression freezing point, and osmotic pressure colligative property. ठीक है. So this is the colligative property table, that is a NaCl dissociation, theoretical and experimental. ठीक है. So that will give the I value. So this is the whole chapter. Thank you so much. Please like and share, subscribe. Thank you so much.